Hi folks, welcome to this set of videos that I'm calling a crash course in counting. And it's about fundamental counting principle and combinations and permutations and different ways of counting the number of ways that events can happen. So we're starting in this video with fundamental counting principle. In the video description you'll find both blank and filled in notes. And throughout this handout there'll be some practice questions, and at the very end of the handout there are answers for them. So generally I'll go through a page and have some examples, and then we'll have some time for some of those practice questions. So let's think about this initial setup here. Imagine that you go to a restaurant and it has the following choices for a breakfast combo. You can have eggs or pancakes, you can have coffee, tea, or juice, you can have white toast or brown toast. You might wonder, well, how many different breakfasts are really possible here? So we could write them out. You could have this first one stands for eggs, coffee, and white toast, then eggs, coffee, and brown toast. And then if you make your next one like, oh, it could be pancakes, juice, and brown toast, we're probably not going to get them all if we don't go at this systematically. So I would be thinking, after eggs, coffee, and brown toast, maybe I'd be thinking eggs, tea, and white toast. And then eggs, tea, and brown toast. And then maybe eggs, juice, and white toast. And eggs, juice, and brown toast. And you can think about how many different ones there are. And I'm going to write them all out here. And there we go. I've written out all 12 possibilities. It took a bit of time, but not too much. An alternate way you could do it is by making a tree diagram. You could go eggs or pancakes, and then from eggs you could have coffee, tea, or juice. And from pancakes you could have coffee, tea, or juice. And then from each of those you could have white or brown. A tree diagram is a great way of showing that there are 12 possibilities. Now let's say we go back to the same restaurant for lunch and they offer the following choices: eggs, ham or tuna sandwich, pop, milk or juice, salad or bun. I'm from Prince Edward Island, Canada, so we call it pop. I'm sorry if you call it soda somewhere else. So EPS, EPB, I could write out all the other ones. Okay, I've written out all the ones for egg. It might occur to you at this point, though, that there's going to be 6 for eggs, and there's going to be 6 for egg sandwich, and 6 for ham sandwich, and 6 for tuna sandwich. Okay, and so there's all 18 possibilities. We could have made a tree diagram, but it would have been pretty big. And if we go back for supper and they have more choices, there are going to be a lot of things to write out. So here's another way to think about this. You have, for your main part, or for your sandwich, you have 3 choices. And for your drink, you have 3 choices. And for your side, let's say, you have 2 choices. And the total number of choices, it turns out, is 18. We've shown that by writing them all out. How can 3 and 3 and 2 make 18? Well, just through multiplication. So an easier way to figure out the number of total possibilities is just through multiplying. And that's essentially the fundamental counting principle. The total ways to select a combo is the number of choices for one item times the number of choices for another item times the number of choices for another item, and so on. Now, of course, this doesn't only apply to lunch and breakfast combos. It really applies to anything. So a combo, if we come back, has your choice of super salad, chicken, pasta, burger, pizza, or nachos, and tea, coffee, pop, or milk. If we write out all these possibilities, then it's going to take forever. But our starters, or our sides, we only have 2 possibilities, super salad. For our main part, or our entree, we have chicken, pasta, burger, pizza, or nachos. So we have 5 entree choices. And for our beverage or drink choices, we have 1, 2, 3, 4 choices. And if I want to know all the different possible choices there are, well, it's just going to be these multiplied together. So 2 times 5 is 10, times 4 is 40 possibilities. A common place you'll see this come up is in car options. So cars are only offered in so many colors and so many trims. It seems like there's an infinite number of varieties, but there probably aren't. So a new car is offered in 6 different colors. It can come in hatchback, sedan, or coupe, and it can be automatic or manual transmission. How many variations on the car are possible? So there are 6 possibilities for color. Another thing that you're going to choose is sort of model. And the last thing is the type of transmission. And if you want to know all the different ways that they can produce this car, well, you'd have 6 different colors, 3 different models, hatchback, sedan, or coupe, and 2 different transmission types. There are 36 sort of versions of this car that exist. Another example of this is looking at phone numbers. So we'll look at 7-digit phone numbers. So most of them are 10-digit these days. You have to do 10-digit dialing. When I was a kid, where I grew up, you only had to dial the last 5. It was amazing. So you got a 7-digit phone number. How many start with either 368 or 367? So for your first digit, it's got to be a 3, right? So you have to think about how many choices is that. It has to be a 3, so you have one choice. We're cataloging choices. For the second digit, it has to be, if it starts with 367 or 368, has to be a 6. So that means that you only have one choice. The third digit, if it starts with 368 or 367, it could be an 8 or a 7. Okay, 8 or 7. So that's 2 choices now. And for the 4th, 5th, 6th, and 7th digits, that means that you can choose any number from 0 through 9. So that's actually 10 choices. Anything from 0 to 9, anything from 0 to 9, anything from 0 to 9. So between these 2 prefixes, let's see, you'd have 1 times 1 times 2 times 10 makes 20, times 10 makes 200, times 10 makes 2,000, times 10 makes 20,000. You have 20,000 different phone numbers, which used to seem like a lot of phone numbers, but now that everybody has their own number for cell phone, we're in a situation where we need more digits. We need 10-digit dialing because we've got more numbers to go around. So that's the basic idea of fundamental counting principle. It's the number of ways you can select one item times the number of ways you can select another times the number of ways you can select another. In terms of practice, I'll scroll through it, but the PDF is down below. So here are a few. Okay. And on the very last page, there are answers. So I'll go straight there. Here's our answers page. There are the fundamental counting principle questions, 1 to 15. I suggest you just give these a shot, but if you'd like to do a couple of them with me, feel free to stay on, and I'll do maybe 1 or 2 of the easier ones, and then 1 or 2 of the ones that are often a cause for some stumbling blocks. How many possible combinations are there from 5 pen colors? So you've got 5 choices for color, 2 different kinds, so the number of ways you can select the kind, maybe they're fat tip and medium tip, okay, and 4 different colored notepads. So this is going to be a set of a pen and a notepad. Well, that'll be 5 times 2 times 4 is 40. Okay. Here's another one where you choose for food, steak, chicken, or turkey. So let's call that main. 3 choices. 4 vegetables. So 4 veg choices and 4 drink choices. If we multiply those together, we'll get 48 possibilities, okay, without having to list them out. A couple that often cause issues. True-false quiz has 3 questions, and how many ways can it be answered if all the questions must be answered? So you have 3 places to make a selection. You have your first choice, and you're either going to say true or false. That's 2 choices. You have your second question. It's either going to be true or false. That's 2 choices. And your third question is either going to be true or false. That's 2 choices. And that's 8 possibilities. People often write 6 for some reason. Even if you listed them all out, you'd see that there are 8. Next one, a true-false quiz has 2 questions, and how many ways can it be answered if a question may be left blank? So there are only 2 questions now, 2 places to make a choice or a decision, the first and the second. But it could be true or false or blank. Now, it's not good if you leave a true or false question blank. So that's really 3 choices. And the next one, you have 3 choices. So 3 times 3 makes 9. Multiple choice test has 4 possible answers for each question. How many ways are there to answer a 5-question test if questions cannot be left blank? Again, I suggest you try this on your own. But there are 5 questions, so 5 places to make a choice. And for each of them, you have 4 options. And you're not going to leave them blank. So that's 4 times 4 times 4 times 4. Or 4 to the power of 5 is 1,024. Okay. If you guess at every question, what's the probability that you get 100%? Well, there's only one way to answer it perfectly right out of 1,024 possibilities. So your chances are very low. One last kind of common stumbling block one might be this last one here. The student body is going to select a president, a VP, and a treasurer from a group of 320 students. How many different ways can the selection be made? So let's say that we have a president. There are 320 possible choices for that president. Now, the same person cannot be the vice president, so you have 319 choices for that. And you're going to have a treasurer, and that person cannot be the president or the VP, so we have 318. And we can head to a calculator and check this out. And it turns out there's a lot of ways for that to happen. There's 32.5 million, essentially. And that brings us to the end of this video on fundamental counting principle, which is a very powerful tool in figuring out how many possibilities there are in a given situation. And that question of out of how many is a key question in probability. I hope this has been helpful. Good luck with the material, folks, and take care.